VLPSos here. This is a video lesson for Python programming special methods. I recommend pausing on occasion to practice. Special methods are functions that belong to a class that are not called by name, but by special circumstances. Special methods are identified by double underscores around their name. The special method double underscore init double underscore is familiar to us. It is automatically called when a new instance is created. We're going to create a class called student. Its code has already been written. Inside of the class declaration, we have defined the special method for creating instances called init with the double underscores around its name. This student has 3 attributes. Enrolled is assigned to be the value in true, and name and grade come through the argument. We could create a dictionary. We will create a dictionary called school, empty at the beginning, and then we will put 2 instances inside of it. One with a key katon equal to a call to the class student, and we'll need to supply the name, which is the same thing as the key katon, and grade, which will be the string 8. This creates an instance and stores it in the dictionary. Remember, of course, that the variable self is not passed in the argument. Self represents the particular instance, and it is stored in computer memory and kept track of automatically, so it doesn't need to be passed. But self is in the argument of init. I'm going to create a second student instance with a different name, which will be the same thing as the key in the dictionary, and a different grade. 2 instances have been created using the special method of the class. If we save and run, we don't access those instances, we've just defined them and put them in memory. There are many special methods that can be written for a class but don't need to be. Most give you very precise control of how Python behaves and are more advanced than our everyday needs. For example, we are familiar with what happens when we use the plus operator. What happens when we use it on our instances? So we have 2 instances of student. And we are familiar with being able to add primitive data types like integers and strings. But what if we use this operator on our instances? It would look like this. We refer to an instance by accessing it in the dictionary that it's inside with its key. And we're going to add to it the other instance inside the same school dictionary, but with a different key, dojun. I'm going to save and run. And what we get is an error. And in the error report it says, unsupported operand type plus student and student. So it's telling us that it doesn't know what to do with the plus operator when we're trying to add objects that are students instead of things that it already knows how to add, like integers and strings. But we can tell our class what to do if the plus operator has been used. We simply need to include a special method to tell our program how to add when instances are added. So we're going to write a definition for the special method add with the double underscores around its name. And what we're going to add is an instance and another. So self is included in the argument, as well as another variable, other, that we'll have to supply when we call or when we use the addition. What we're going to do is, instead of write an error, our program will now use this method, and we can make our method do anything we wish. And what we're wishing to do is simply print this line. Now when we run our program, instead of causing the error, our program now knows how to use the plus operator. It looks to the add special method that we wrote for it, and it does that line of code. It doesn't do anything with the instances or their attributes, it simply prints that line. Dojun and Catan are brothers. Adding them together prints all, look at the brothers working together. Yeah, it doesn't make sense to use plus in the traditional sense, but we can change that. Use of the plus sign is just a call to the special method ~add_. By rewriting the add special method, we can write whatever we want to happen when we use the plus on instances of our class. And remember, we are only changing what happens with instances, not the entire behavior of the plus. Because the add method belonged to the class, it doesn't mean that we can't now add integers, because the integers are not instances of the class that the special method we wrote works on. Moving on. Let's take a look at and modify one more special method. The ~str for string _ method. str is short for string. It's what is called when the common print function is used. So I have pre-written some code that we're going to include in the class. And uncomment it. This definition is a special method. It's the string special method. It takes the instance as self, and it may access attributes, but the string special method creates a string and returns that string to be printed, because it's the print function that accesses this special method with this name whenever something is printed or whenever an instance of this class is printed. The string special method will take the instance, start by creating an empty string, and then add several lines to that string. So in the end, there's only one string that's being created, though it might have, it does have several different parts. Notice that whenever we add a string, the new line character is at the end, so that when this is printed as a single string, we'll see it broken up and print this over several lines. It creates a string that has some graphics and supplies the name and the grade of the attribute that is being printed. And then it returns the string. The string special method requires a return of a string. No matter what else might happen in this method, in its code block, a string has to be returned because it's expected. This method has been designed to only create one string and then return that string. So we can access this method now if we use the print function. And we're going to print the two instances in our school by iterating through the school dictionary that contains them. And we're going to add a little complication. If the enrolled attribute of the current instance is true, then we'll print that instance. And in so doing, by putting an instance into the print, it's going to look for the string special method in order to handle it. Let's save and run, and we see what it means now to print out an instance of our class. If we didn't have that special method written, we can comment it out to remove it. We can see what it would look like to print. In this case, all we get is a report that the student object is in a place of memory and not the nice printout or display of what it means to be a student or the attributes. So writing the string special method is very often a desirable, common special method to include. A comment about what we just did, but including our own string special method in our class gives us control of what our instances look like when we print them. Python expects a string to be returned to the print function, so we have to remember to code for that. And what that means is a reminder that we need to return the string. Now you. With special methods, you have seen how to override some of Python's basic functionality to make it do what you want when working with instances of a class. Write a simple program that makes a few instances of a class and write a string special method to display what you want when you put one of your instances in the print function. And have fun.